So, good morning, students. So, today we will continue from yesterday's part only, means where we left yesterday. So, sorry for the delay. Actually, there was some issue with the network, basically. So, you can open page number 232 for your, I mean, from your this OPPDF. So, yesterday we saw various types of, yeah, some types of inheritance. So we had seen your single inheritance. Then yes, good morning to all again. So yesterday, what did we study? Basically, we had studied the visibility scope, means how you can inherit different class members into your base class. Sorry, in your derived class. So we had seen examples of single inheritance. Then yesterday we saw your how you can make private members inheritable, what was protected member, and what is the protected visibility scope. So we had seen these things yesterday. We had also seen multi-level inheritance to an extent. So today we will start from multiple inheritance. So you can move to page number 232. So what does this multiple inheritance mean? It basically means that you are inheriting from multiple base classes. So if you see the figure over here they have got say three base classes B1, B2, say up to n classes you can have based on your requirement of the program. You can have as many number of base classes that you want. So D is the derived class which is deriving the properties from all these base classes. Okay, so what is the generalized syntax? You can move to the next page. You will see class D followed by a colon, then visibility scope of the base classes. So if there are n base classes, you have to specify the visibility scope for all the base classes. Then you can have this body of the class that you want, and you can define your data members and member functions wherever you means whatever you want. So because you can go to this object oriented uh, programming folder, there you will get I mean it is there in your Google Drive PDF and everything. So there in the theory folder you will get this C++ by E Balaguru Swami. So you can open that PDF and move to page number 233. Okay, so I think many of you are attending this, means you don't attend regularly. So should we go for this online attendance? What's your means suggestion on this online attendance? Why? No, simple in normal classes also we have attendance. So in online class also we can have attendance, right? So that will be more better, I think. If I have actually I have thought about it, online attendance. So during class I will say upload a form where you will just write down your roll number and date, or say it will be basically a drop down list. ठीक है, so I will give it in say some specific time. So within 5 minutes, all of you have to, I mean, submit the form. So it will be means time will be there. Don't worry, but that will be random. If I am taking live session, so at which point of time I will be uploading the evidence, that will not be predefined. So कभी पहले भी हो सकता है, might be maybe towards the end of the session. Sir, I live in village network to bed here, sir. So you will get some time, 5 to 10 minutes. You will get to fill up the attendance sheet. So 5 to 10 minutes, I think you can get this stable network. And also, if you are not able to fill it up, you can just text me later on. Okay, let's move to our discussion. So in this example, you will see that they have taken two base classes M and N, and finally there is a derived class which is my P. So you will see class P followed by colon public M comma public N. So it is deriving from both the classes M and N. Now public void display. So class N, M and N have been specified as follows. So the contents of this class M and N are also given. So you'll see that get M is there, get N is there, and if you move to the next class, so you'll see the derived class P is declared above would in effect contain all the members of M and N in addition to its own members as shown below. Okay, so I think this is quite intuitive as all of you have understood this inheritance. What does it mean? So all the data members and member functions will directly be a part of the derived class. So by default, I think there is no problem in this. So all the data members, if it is declared in this public section, so everything will, and if you are inheriting it also publicly, so everything will move to your public section. So after this, what they have done, they have defined a display function for your P. Okay, so this is also quite simple to understand. I don't think there is much problem in it. So after this, they have gone for this main function where they have called the respective member functions. So get M is a part of P now. Originally, it was a part of M, so it has been called. Get N was a part of N, so it has been also inherited in your P, so you can also access this. And finally P dot display. Okay, so this is a small example to implement your multiple inheritance. Okay, now although they have not given this entire program in a sheet along with some explanation, but if you code it in continuously also, I don't think it will be much difficult to run. Okay, they have also, I think they have given it, huh? Next page they have given the entire code. So you can implement this. मुज़क्किर ये सब एनसी सी प्लस प्लस का कितना नंबर पेज पे है? Uh, which PD? I think this is from your Balaguru Swami PDF. राहुल मोहतो इनहेरिटेंस का वीडियो तो आप दिया था, हाँ. सो दैट वाज a basic आई मीन वीडियो. उसमें ज्यादा कुछ नहीं था क्योंकि yesterday we covered up your feasibility scope. So वो so next there is a problem here. Or we have topic in page number 236. You'll see that something known as ambiguity resolution. Okay, so what is this basically? Now, as because we are going for multiple inheritance, so we have derived from say 2 3 base classes, right? Now, if you all remember that there is something known as this display function. So traditionally we uh, so traditionally what we do, we have these display functions for almost all the class definitions, right? So we are assuming a scenario where say class M is having this display function, class N is also having a display function. So in that circumstances, if you are inheriting from those base classes, which display function is going to get called? So I hope this ambiguity part is clear. So if you have got in means if you have got a function with the same name in two or more base classes, so when you are deriving it in your derived class, so means which will be called if you invoke that particular function. So there will be this sort of ambiguity. So what happens? So you will see which display function is used by derived classes when we inherit from these two classes. So what we can do is one way to solve this is to use a named instance of a function. Okay. So whenever, so just try to follow this example that is given here. So here you will see that class M is having a display function, class N is also having a display function. Now in class P, public MN means you have derived everything publicly from MNN. So here you will see that if I am I want to call the display function for from the class M, what I can do is I can have a named instance. So here if you see this first part of page number 237, you will see that M followed by scope resolution operator then display. So this will call the display function from the base class M. So you are actually having a named instance of the particular member function, means which class it belongs you are explicitly calling. So whenever you are defining or calling or basically using the same function name, what happens is whatever is there in your derived class, that will override the previous base classes. So now in this case if you have given any other definition, so it will be overwritten, means whatever was the contents of your M and N, that will get overwritten with something else. So this phenomenon is also known as your overriding. So is it clear? Okay, so here again in the second part, what they have done. So ambiguity may also arise in single inheritance. So, for instance, consider the following situation display, and in say this is the base class A, and B is your derived class. Okay, so in this case, the function in the derived class overrides the inherited function, and therefore a simple call to display function by B type object will invoke function defined in B only. However, we may invoke the function defined in A by using scope resolution operator to specify the class. So this is the same thing that I was telling. So if you are not or if you want to explicitly call the member function which is derived I mean defined in a base class, so you can use the scope resolution operator. Or if you are defining it in the base class, sorry, in the derived class, so this contents will be overridden. So any doubts? So is this part clear? Yes, what is not clear? So Iftikhar, can you specify what portion is not clear? Say, okay, you can move to figure, page number 232. Say, there we have got a diagram, right? D. Then I have got some base classes B1, B2, Bn. Now, let's assume all these base classes. Okay, so okay, I'll just continue. So let's assume all these base classes have got a display function as a member function. So when you are deriving these contents from all the base classes, so effectively in D, if you invoke this display function, which one will get called? Okay, one approach is to use scope resolution operator to explicitly specify which base class function you want to call, and in the other case what you can do is you can define it in the derived class. So in that scenario, the entire contents of the display function will be overridden. Okay, so yes, all of you don't need to give this present, sir. So I will, if you want me to take attendance, I will design an explicit interface for it. Okay, so there is no point in giving this present, sir, here. Even I can see how many are connected, so no issues with me. So ambiguity resolution is over. Next comes hierarchical inheritance. So you can move to page number 238. So there you will get a diagram. So hierarchical inheritance or hierarchy, what does it mean? Any, what does hierarchy mean? Any answers? See, basically hierarchy means data, or say hierarchy means what? Level by level you can segregate the data. Okay, or you can segregate the objects or classes, whatever you want. If you see this particular example only, say students. So this is the generalized hierarchy or generalized level. So students can have, yes, to an extent, yes, you are correct, tree like. Means what? Students can be, or here as the example goes, students have, or they might belong to arts, they might belong to engineering, they might belong to medical. So student is the the generic object, or say class, whatever you have. And then what you are going for, specialization means what? You are again building upon that, means whatever was there in your original hierarchy, so you are then going for specializing. Now again in engineering you can have this division, which is mechanical, electrical and civil. So basically means what? You will, or if there is this hierarchical organization of data, so you can again incorporate this inheritance there. Okay. So hierarchical inheritance, basically it is means up till now whatever we have covered up, single inheritance, multiple inheritance, multi-level inheritance. So by using this only you can implement this sort of inheritances. So even in case of if you move to page number 213, and we have got next now something known as hybrid inheritance. So uh, we can also write programs of this type of inheritance with the concepts whatever has been covered up previously. Okay. So in the book also they have not given, yes, there is an example. So where they have given means a sample program for your hybrid inheritance. So we can move to page number 240. So I think they have used this student, uh, I, I think example. Yes, multi-level. So they have implemented this figure 8.11. So they have written the program. So I think this is easy to understand. So there is no as such or confusion should not be there. So they have just derived the respective classes, and finally they have created the object. Okay. Now next concept, if you move to page number 242, we have got something known as virtual base class. Okay. So we have seen multiple inheritance, we have seen multi-level inheritance, we have to an extent seen hybrid inheritance, and also your say hierarchical inheritance. So move to figure 8.12. So if you have got this sort of hybrid inheritance, say here, just consider this example. Say we have got a class grandparent which is having two childs, parent 1 and parent 2, and both of them are having or they are again further having a child class which is your child. Now as we all know, whatever contents you are inheriting, if it is inherited publicly, so all the contents will directly move to the base classes. Now there might be situation. See, you have derived parent 1 and parent 2, both of them have derived from grandparent. So whatever contents are there in your grandparent, say I am deriving the contents publicly. So whatever contents are there in my grandparent, both parent 1 and parent 2 are having. Okay, single copies. Now child, when I am deriving is because I am having this multiple inheritance. So child is deriving from both parent 1 and parent 2. Now in this case, what will happen, you will get multiple copies of the functions or data members whatever was present in your grandparent. Means it will inherit the contents twice. Okay. So you can also read here, all the public and protected members of grandparent are inherited into child twice, first via parent 1 and again via parent 2. Means what, it is now going to have duplicate copies of the members of grandparent. So how can we resolve this? We can resolve this by defining the grandparent as a virtual base class. So when a class is made between the virtual base class and derived class. So C++ will explicitly take care that your final derived class will have only a single copy of the parent class. So is this thing clear? Virtual base class, what does it mean? So whenever you are going for multi-level inheritance, so yes, whenever you are going for this multi-level inheritance, so if you are declaring anything as a virtual base class, so only one copy of the network will pass. You can move to page number 243. Yes, book page number is 229, but PDF page number is 243. So just try to relate it. You will see that in this example, you have got a grandparent which is having two children. So parent 1 and parent 2, both of them are deriving from grandparent, right? So both of them will have copies of the public or protected member, whatever you want. Now, when child is deriving from parent 1 and parent 2, it is likely to have multiple copies of the members of grandparent. Okay. So to resolve this issue or to resolve this ambiguity, we have used this virtual base class. So what does or what will it do? It will ensure that child class or the final derived class will have only one copy of the grandparent, okay, or the virtual base class, so that multiple copies are not created. So is it clear, Upasana? So you can see here in page number 244 they have given an example. So result is the final derived class which is inheriting from test and sports. So these in turn are inheriting from student base class. So they have defined this student class as a virtual base class, so that only one copy of the members of student are passed to the result class. So you can just follow the example. You will see that class test virtual public student means student is now a virtual base class. Okay, then they are defining the member functions and appropriate data members whatever are needed. So finally, class result. public test. So we are inheriting from test and sports. And finally, so you can implement this example and you can see how this is working. So next 246. So what is an abstract class? So an abstract class is designed only to act as a base class to be inherited by other classes. It is a design concept in program development and provides a base upon which other classes may be built. So in the previous example, student class is an abstract class since it is not used to create any objects. Okay, so abstract class basically means what? The class whose object will not be created. Okay, so you are not creating any object for the abstract class. So this is only there to support the design of the program. Okay, explicit objects of this class are not created. So they have given you an example also, means in the previous program, student is your abstract class because you are not creating any object of for your this student class. Okay, so I think next we have the final topic here, which is my constructors in derived class. Now, what is a constructor? What is a constructor? Class name and function name is same. Okay, but what is the use? Okay, used to initialize object. So it is basically used to initialize the object. You should not say that class name and function name is same. Huh? That is there, but that basic, uh, requirement, or you can say the objective of a constructor is to initialize objects. Okay, now its syntax is as such that its name is same as the class name. Okay, so these things should be clear to you. Although it is having the same class name and function name, but what is its primary task? Its primary task is to initialize the objects. Now its syntax is as such, the derive, the name of the function of the constructor is same as the class name. Okay, now you can move to page number 247 according to the PDF number, page number. So just see that there some representation is given. Okay, so general form of defining a derived constructor is derived constructor. So this is the name of the constructor. Argument list 1, argument list 2, argument list n. So argument list 1 will go to your base 1, argument list 2 Pooja, can you please specify what you are trying to tell? ऑब्जेक्ट कॉल करने की जरूरत नहीं पड़ती. I am not actually clear what you are trying to say. Okay, we'll move to our explanation. So argument list 1. So what happens is, means these arguments, now we are assuming that our derived class is inheriting page number 247. So we are assuming that our derived class is inheriting from these base classes, base 1, base 2, base n. Okay, so base 1 is, or we are assuming that base 1 is the same name for the class. Okay, so argument list 1 will be first passed to base 1 as a constructor. So you are actually explicitly calling the base 1 constructor, means the class, sorry, the parent class base 1. Now base 1 argument list, base 2 argument list functions are the function calls to the constructor base 1, base 2, and therefore argument list 1, argument list 2 represent the actual parameters that are passed to the base constructor. Okay, so what we have to do is, in case of multiple inheritance, the base classes are constructed in the order in which they appear in the declaration of the derived classes. So you have to initialize or call the constructors in the order that you have derived it. Okay, means if you have used say base class 1 first, so you have to call the base class constructor first. Okay, so we'll just try to read it from the previous page. So as we know that constructors play an important role in initializing objects, we did not use them earlier in the derived classes for the sake of simplicity. One important thing to note here is that as long as no base class constructor takes any arguments, the derived class need not have a constructor function. However, if any base class contains a constructor with one or more arguments, then it is mandatory for the derived class to have a constructor and pass the arguments to the base class constructor. Remember, while applying inheritance, we usually create objects using the derived class. Thus, it makes sense for the derived class to pass arguments to the base class constructor. When both the derived and base class contain constructor, the base constructor is executed first and then the constructor in the derived class is executed. So as long as you are not having any constructor defined in your base classes, there is no need to define the constructor in derived class. But if your base class is having a constructor, if it is defining constructor, so it is mandatory that you have got constructors in your derived class. So if you are having or if you are declaring constructor in derived class, so what it means, you have to explicitly call constructors of the base classes. So you have to pass explicit arguments to call the respective base class constructors. So I think next page they have got a, basically page number 249, they have got an example, you can just see it. So here they have got uh, two base classes, alpha and beta. So they are using two constructors there. It is a parameterized constructor. So finally they have defined a derived class which is gamma. So gamma is inheriting from both beta and alpha. Okay. So if you see the definition for this gamma constructor, first it is passing arguments for alpha, next it is passing arguments for beta, and finally for the base, I mean derived class itself. So you will see A is passed to alpha constructor, B is passed to this beta constructor, means the constructor which is initializing these classes. and C and D are used by or used for the derived class itself, because there are some data members in the derived class, so C and D are used for it. So concept is quite straightforward, not there's no much of say theory or some ambiguity. So that's up. I think this is sufficient for your inheritance. So next we can go for pointers, virtual function and polymorphism, and say after this we can have IO and finally your say error handling. So this will roughly cover up your object oriented syllabus. To an extent, we have covered up almost the major parts of your object oriented programming. I think it is covered up. So once we cover up this, we can explicitly focus on, I mean, our computer architecture. So any doubts? Any doubts? If you want, you can ask. Okay, then thank you. I'm ending the stream now. So should we take class tomorrow? Computer architecture is hard to understand from this type of video. So what do you want for computer architecture? See, computer architecture you have to read. There is nothing that I can do. Okay. Unless, see, understanding programming languages are easier. But computer architecture you have to explicitly read because this is a circuit. Okay. So if it is means whatever the users have defined or the designers have used, so we have to read that only. There is no flexibility there. So you have to read it. So computer architecture also I am likely to take up in this way so that it is easier for you to follow. So okay, next class we can have tomorrow. Yes, I will take computer architecture only tomorrow because this thing was pending. So I also actually I thought of covering it up, taking this for half an hour and next computer architecture for half an hour. So, but there was some problem with the network, and so I was a bit late. So tomorrow we'll take up this thing. So tomorrow we'll try to start from 9 or 9:30 because after this 9 and 9:30 some problem comes up here in my house. So it becomes something a bit difficult for me to manage. So we'll take up computer architecture, and I think we'll take up magnetic disk. If okay, I'll share some problems also there. So we'll try to follow the problems, and then we'll move to optical disk and RAID structures. No, I'm not taking attendance right now, but yes. See, unless and until you guys come into the live session, it is very difficult for you to understand also, and also I mean it is difficult for you also. If the topics are not clear at the end, then you will only suffer. Okay, because there is no problem for me, right? Because I'll tell that I have covered up this sort of topics and I can place questions from this part in your exams. But if you, or if the concept is not clear from your side, you will only be at problem, right? So it is very essential that most of you turn up for this live classes. So tomorrow's class tentatively from 9 to 9:30 I'll start. Tentatively by 9 I'll start, but if any sort of problem, because for connecting also it takes up a bit of time. At least 5 to 10 minutes it takes up. Tomorrow's class, yes, we'll cover or we'll start with computer architecture. Okay, means previously we have seen this magnetic disk, and we'll try to take up some problems from magnetic disk based on the access time and this kind of things. And next we'll see optical disks and so on. Okay, then thank you. I will end the stream now. I will try to take attendance tomorrow.